Hey everyone. So in the last video, we talked about how to use AOVs to output custom passives to break down your image and then recombine them in a painting setup. But there's some big problems. Mainly, AOVs can't do this. AOVs only run when you do a full render. You cannot view them in a viewport. You can't break down your character's various different shading layers into render layers. And if you're working on individual passes in the viewport, or doing things like I did in my earlier Ray project, where you want to paint into different passes in 3D, not just in post, then you need this option. AOVs also have other major limitations. They can only output color or value slots. They can't actually output a full shader. This matters if you're using something that only outputs as a shader node, or if you're using cycles, where all your outputs are shaders. Another limitation is that since AOVs aren't individual render layers, you can't re-render just one layer like I can with this setup, because I have full render layers here. AOVs are passes on an individual layer, so you have to re-render the entire layer anytime you want to re-render just one pass. The biggest problem with using AOVs, though, is actually technical limitations in Eevee. In Cycles, it's not such a big deal, but in Eevee, you have to have your entire shader compile all at once. If you're using a heavy shader, like me, and you have a lot of AOVs, it has to compile every combination for every AOV, and this can actually run into GPU limits. In this video, I'll be teaching you about how this all works and how to build it yourself. The core of it is a custom script that provides a different value based on the name of the render layer. Whatever value you put at the beginning of your layer name will show up in this driver node. You then use that to control what gets outputted. This basic version of the script does have some limitations and is slightly unreliable, though. Like if I change back to 0, the driver doesn't always change until I refresh the node. That's a bit annoying. So there's also a more complicated version of the script that avoids that problem and works slightly differently. Instead of changing a value in a mix node, it actually changes what's connected to the output node. By only having one input hooked up on any given layer, you avoid the previously mentioned problems of having to compile every combination at the same time and hitting the GPU limit. As usual, you're welcome to follow along and build this for yourself, which I guess in this case would mean copying this off the screen. Or if you want to save yourself the hassle and help support me, then you can sign up for my Patreon, where these will be available to my Tier 2 and higher supporters through the end of July 2021, or you can get them on Gumroad for a few dollars. We're going to work in these simpler demo files instead of the main character file because, well, the compile times are terrible, and we can't afford to wait a couple minutes for it to recompile every time I change a node. So we'll work here, but then once we understand what's going on, we'll go see what it actually looks like on the big project. Let's take a look at what we've got here. We have 4 render layers, numbered 0 through 3. The exact same things are on each layer, but it's rendering a different material. Of our 4 inputs, we have a diffuse, a glossy, a Voronoi texture, and ambient occlusion. And these were just arbitrary things I chose because they look different at a glance, so we weren't going to get confused. Inside our group here, we have our driver node giving us our value based on our render layer. Sometimes it doesn't update. Sometimes it does, like I switched to 0 and the shader changed to the right option, but the driver value itself didn't update visually. And that's because Blender isn't always the best about updating certain parts of the UI on layer changes, and about firing the driver dependency update. So we can refresh the driver by muting and unmuting the node, or by hitting enter and reassigning the expression. Or if we opened up the driver's editor, we could hit update dependencies. The value from our driver node is then used to control these mixed shaders between the 4 input layers. And we have to subtract 1 from it, or 2, one per step, let's say, to get the right outcome. So for a value of 0, it goes for the first socket of the first mix shader, and 0 minus 1 clamped is still 0, has to be clamped, so we get the first output of the second and the first output of the third, so we still get socket 0. Then if we go to like a value of 3, then 3 clamped is still 1, so we get the second socket, and then 3 minus 2 is 1 clamped, second socket, but second socket. So you get the idea, and you can do this with as many sockets, with as many mix nodes as you need. So the real magic, of course, is this Python script that makes this driver work. Now, I know most people watching probably aren't scripters or don't know Python, but don't worry, you don't really need to. We're going to walk through this on a conceptual level just so you understand how this is working overall. You don't need to worry about all the technical details because the scripts are already written. Normally, when we think of drivers, we think of getting access to transform properties like something's x location or rotation or scale, or we think of mathematical expressions. But you can also run essentially Python expressions. I mean, all driver expressions are Python, so you can run things that are Python other than doing math. What this script does is it runs when the file is opened, and it defines the thing that the driver references. If we look at this driver in the driver editor, we see that the expression is layer number depth graph. This is referring to something called layer number that we define in this script. So what this register function actually does is it makes this def layer number available to drivers through the dependency graph. That's why our driver expression can access it. Otherwise, if you have this driver expression and this script hasn't run, then Blender has no idea what you're talking about, and this will just return an error. So the first function of the script is to provide this def to drivers. Now what this def actually does is pretty simple. It looks at the name of your currently active render layer, whether in the viewport or while doing a full F12 render, and it looks to see if it starts with a number and a colon. If it does, then it returns that number as the driver value. If it doesn't, like if there isn't a colon, or if there's no numbers in the render layer name, then it just returns 0. And that's the entire thing it does. It's pretty straightforward. So if I change this render layer to be named Moo, and then go there, and now I go to Moo, it's just going to stay 0. So our driver setup is working great in the test file, but let's flip back to the main character and take a look at what it would be like in a complex setup. So I've got all of the layers coming out of my shader and a bunch of the colors that I'm taking straight from an input rather than feeding through the shader group, although that probably makes no difference. And I have my 6 layers laid out here. And I have 2 groups, one for the driver mix and one for the connection method. So with the driver mix group hooked up, let's render. And the shader is compiling. Slowly, time remaining, 3:39, time elapsed 36. I think we're going to have to skip ahead on this one. It took about 5 minutes to compile the shader. But now that it's compiled, it does work in real time. And I can switch to these other layers, which will take a second because I've got subsurf enabled, but it does not have to recompile the shader. And in fact, the compiled shader lives on your disk in user app data local NVIDIA GL cache. So if I delete that GL cache, then I'll have to recompile again. But it's pretty good about saving the cache through, even if you close Blender or reload the file or something. Of course, if you change the shader tree, then it'll have to redo it. And sometimes it's good about keeping multiple copies of the shader, and sometimes it just throws out the whole shader for no reason, so it's really unreliable. Now, the reason it took so long to compile is not just because the shader is big, but because there's essentially 6 copies of it that we've made it compile all into one. So that's a lot to ask from it. If I just have the regular combined shader, it's still a good minute or 2 minutes of compiling though, as that is the most complex layer. But it's not great. So this driver method is nice in that you get all of your compiling done up front, but it's still really slow. And there's actually a bigger problem when we go to really render it. If I do a regular F12 render, it's going to render out all 6 of these layers. So let's hit that. And this is probably going to take a few minutes, even just at 1600 by 1280. So let's skip ahead again. Alright, so the render's done and we're clocking in at 5:53, nearly 6 minutes. We do have all 6 of our layers there, but man, that's pretty bad for Eevee at a resolution this low. So why is it so bad? I thought our shader was cached already. Well, when you F12 render in Eevee, it has to recompile the shader for every layer, even if it's already cached. I don't know why it works this way, and they are talking about changing it, but for now, it just makes rendering multiple layers with a heavy shader really slow and impractical. And that's not even the end of our troubles. We go back to the shader nodes. You may notice that I don't actually have all of my nodes plugged in. What happens if I plug in the rest of these? It's going to have to recompile, even though it already has most of this cached. I'm going to open up a console because I know what's going to happen in a minute. I guess I can use this time while we wait to talk about this layer setup here. So I want to be able to view my combined and shading and gloss individually, so they're the only thing on those render layers. But the rest of these layers are just about packing in data to get it out into the compositor and then output it to files. So what I'm doing here is plugging in my data passes into the color sockets, because in render layer passes, you can output just the color or the specular color or the emission color. So that actually lets you get lots of data into one render layer by adding them together. Of course, it looks a bit silly in the viewport or the combined render pass, as you may have noticed when I flipped through the layers earlier. But it works just fine for just getting the data out. So that's a nice trick. And on this one, I'm even combining RGB and adding even more together. And boy, this is taking a while, so let's skip ahead again. Alright, we're back, and when you look at this mess, we've got pink on the hair, kind of like a missing texture. But what it actually is this big GPU error that we've got on the console. And if we look at this line here, we can see the error is too many instructions. It's still compiling some of the other shaders, but it's given up on the hair, and it may pink out some of these others too that aren't finished. So this is what happens when you just have too much stuff trying to be compiled at the same time, and it's too much for the graphics card. And the breakpoint for having too much in the shader just happened to be these 2 extra layers, my line color and world color. That's just too much for it. Now, of course, if I remove things from another part of the shader setup, then I'll get around this problem. But it's still just not an issue you can really work with. What if I wanted to have like a background scene or a second character? You know, I want to be able to use really ridiculous shaders. And the real problem is that it's having to compile everything all at once. If it's just the combined pass alone, then I can use tons of crazy procedural textures and stuff without hitting this issue. So clearly, between all of these different problems with this driver-based method of mixing between layers, it's just not going to work in a character this complicated. And note, if we were using an AOV setup with the same amount of layers, we would have the exact same problem. So let's move on and take a look at our more fancy script setup, where instead of mixing between different inputs, it just switches the input. And what this means is it's only going to compile one part of the network at a time. This version of the script is much more complicated, and to help figure it out, I got some help on Stack Exchange. So let's all thank Chris over on Stack Exchange for answering my question, and I'll link this in the description because it contains most of this script and explanations about how more of it works. Let's take a look through the script and see what's been added. Our original layer number def that we looked at before is still here, and it's still providing the number for this driver expression. And we also have def connect output, which is the code that actually handles plugging one socket into the other. And which input it plugs in is based on the number it gets from the layer number def. These first two defs are actually called in this third def, where we can see it calls layer number and connect output. And this line here, this is the first line that isn't inside a def, is what actually runs these. It runs this, and this runs these two. Then at the bottom, we have two more defs, which are being run by register, which is the name of one def, and inside that it runs load handler, which is the other def. So this line runs my handler, which runs layer number and connect output, and register runs register, which then runs load handler. The reason we have two is because one is for the viewport and one is for F12 renders. So there's a bunch of different handlers being registered and the driver being registered, just like before. Even though we're not using the driver node, I've left it here just so we can be on the right index and know what index we're on. There's another nice little bit of code I've added here. If you notice, as we flip through these, even when we go back a number, we're not having the problem we saw in the previous file where what's rendering and the driver number gets out of sync. And that's because of these lines. Before, we've solved that problem by muting and unmuting the node, or by selecting this and hitting enter. And what happens when you select a field and hit enter is you're actually reassigning the expression, which causes the driver to update, to run again. And that's what these lines are actually doing. Each time a connection is changed, it takes the driver field of this node and sets it to be equal to itself again. And that forces a refresh. And that keeps our layers clean. So now that we get what's going on with the fancier script, let's try it out on the full character file. This should give us just the first layer, the combined layer. We'll still have to put up with compiling it. Alright, that still took a couple minutes to compile because it's still the complicated combine shader, but it was significantly less time than before, because it hadn't compiled all this other stuff. Which means the first time I change to those layers, it is going to have to compile them too. But that doesn't take anywhere near as long. Let's see here. Gonna manage it. This is just the diffuse shading, which is about the second most complicated shader to compile. And now if we go back to combined, it's still saved. We don't have to recompile. So if we want to flip through all of our layers, we still have to bite the bullet and eat that compile time up front. But if we're only working on a couple of layers, we don't have to worry about compiling all of the others. We're never going to entirely get around the compile issue because Eevee just wasn't really intended to be used with shaders this complicated. But this is certainly an improvement in workability. Now let's try an F12 render and see how it compares. And it's done, this time in 3 minutes, so half the time of the mix node version. Now, it's worth noting that these render times can be a bit inconsistent because there is a bunch of stuff going on with the caching. I ran a bunch of tests, both with some things cached already in the viewport and from a completely fresh file, even wiping the caches on my disk, and I got pretty inconsistent results for both setups. But the point is, the Connect setup is way faster than the Mix setup. And we've also not overrun our GPU instruction limit. Okay, so to do a quick recap, AOVs have a bunch of limitations, so to get around them, we use multiple render layers and change what nodes render on a given layer. We change it using a setup based on a value that comes from a driver, and the driver works because a script loads some stuff to the dependency graph. There are two setups where we can use this. The first is a mix-based setup, where we compile everything together and then use the value and multiple mix shaders to mix between our layers. The second option is the connect group setup, where instead the script doesn't directly use the driver, we leave it in there, but the script instead changes what group input is plugged into the output. Which one of these setups you use depends on the nature of your project. If you have a fairly simple shader, and you're not going to have bad compile times, then just use the mix group, because then everything compiles up front and no more problems. If you have a very complicated setup and shader like I do, then you need to use the connect group to avoid hitting the GPU limit, and so that your upfront compile time isn't so crazy. And if you have compile times at all, the connect group is probably more efficient when doing F12 renders, where it's going to recompile a bunch of stuff per layer anyway. Now, regardless of if you're using a connect group or mix, the fancier version of the script is still better to use, because since it's actually calling the script with the handler, it's going to refresh your driver. So you can use the fancy script and use the same driver. It's the same expression in either version of the script. So you can do this group and still be running the connect version of the script. Now, after watching through all of this, you might be thinking that this all seems like kind of a pain in the ass. And to some extent it is, but the reason it seems so bad is because my shader is so heavy. If you have regular PBR shaders and aren't doing a bunch of multi-layer crazy NPR stuff, then you basically just load the script and make the group once, and it's all easy sailing from there. So I'm intentionally demonstrating this with a really complicated setup that's about the maximum complexity you can do to show how far you can take it, but don't let that put you off using these sorts of methods. And it's likely that a lot of these things are going to improve, hopefully in the near future. Back on June 4th, we got this Eevee developers blog that talks about render passes and real-time compositing. So hopefully we'll see some improvements to compile times, or maybe compile caching. I think that's been talked about as well. Or maybe we'll see just generally better support for some of these things and better performance. So I have no idea when that's coming. I'll link this blog post in the description if you want to read it, but there is hope for improvements to all this in the future. That's all for this video. I'll be putting up both scripts on Gumroad and sending them out to my Tier 2 patrons. I'll put the basic one for free and the fancy one for a few dollars. So please consider picking those up or subscribing to my Patreon if you want to help support me and keep me making more content like this. And maybe in the next video I'll actually be able to finish up some artwork using all these fancy things. Thanks, and I'll see you next video.